So quadratics, man. A quadratic is literally just a type of function. It's a type of a function. Type of a function. So guys, in the last couple classes, didn't we look at lines? You know, y is equal mx plus c, and we said lines will look like that. Yeah, you know what I'm talking about? Y is equal mx plus c lines. Yeah? Yes or no? Tell me, guys. Straight lines. Why are we so quiet?
Yes, sir.
All right.
Yes, sir.
Vanessa, straight lines. You know what's a straight line?
Yeah.
Okay, cool. Kaylee, you know what's a straight line?
Yes, sir.
Okay, Christian, do you know what a straight line is? Y is equal mx plus c.
Yes, sir.
Yeah? Okay. Well, a quadratic is similar, but instead of producing a line, it produces a curve, a smiley face or a sad face. Now, it takes the form of f of x is equal to ax squared plus bx plus c. So anytime you see a function raised to the power 2, and that's the highest power, that's a quadratic you're dealing with. So let me just make a note about that. Anytime the highest power of x is you are dealing with a quadratic. Please real quiet, boy. Nah. Something wrong there. Vanessa. So I say in here that the highest power would be 2. And if that is the case, it's a quadratic. So I'm gonna throw some questions at you quickly. Let's just say we had this function here. We had f of x is equal to x squared. Quadratic or not a quadratic?
Not a quadratic.
That is a quadratic.
What?
That is
Oh,
a
because it is
quadratic.
square?
Yeah. Oh, okay. So this is a good thing we starting this thing from scratch. It's a good thing. Right? So once the highest power of x is 2, you're dealing with a quadratic. Regardless of what you see, once the highest power of x is 2, it is a quadratic.
Oh,
Yeah. And a quadratic could either look like this, or it could look like this. I have a question, right? Christian, this graph looks like it's going up to the top or to the bottom. If you had to see what are looking like.
They're going up to the top, sir.
Okay. So if we're going up to the top, would you say maximum or minimum?
Maximum.
Right. So this is an example of a quadratic with a maximum turning point. We say maximum turning point because it's going up to the maximum point, then it's turning. And this would have a what point? See if I like a guess. If that one is maximum, what do you think the other one gonna be?
Minimum.
Yeah. I tell you, these things more straightforward than you think. Minimum. Now let me give you all some examples of quadratics quickly. So example one. So Vanessa, this one is for you. Let's just say we had a function f of x is equal to x squared. Vanessa, quadratic or not a quadratic?
quadratic.
Yeah, this is a quadratic. Okay. What about, okay, let me call somebody else. Nia, what about 3x plus 2x squared? Quadratic or not a quadratic? Tell me, Nia.
Quadratic.
Yes. Is there anybody here that doesn't understand why this is a quadratic? Christian, in this class, like if I look confused, I could tell man, stop man at any point. So I need you to tell me. You confused by
So
this?
it enters a quadratic because the highest power is 2.
Yeah, that is it. That is. I know it's not looking like it's in this order, but it is still a quadratic. If you wanted, you could have written this as 2x squared plus 3x, and it's the exact same thing. Because when you add in, the order doesn't matter. So instead of writing the 2x squared second, I can write it first. So that is actually a quadratic. What about
Okay,
this one?
sir.
What about this one? 9x squared plus 7x plus 4. Okay, form for people. Quadratic or not a quadratic? Tell me, guys. Quick.
Quadratics.
Yes, that is a quadratic. Now, some of you probably saying, sir, I'm confused. Where you pull this y out from? Now, we did functions previously. F of x represents the output of a function. The output of a function could be represented by what? So remind me, x is the input, and what's the output? Remind me, guys. Y. So if you see me write y instead of f of x, just know it means the same thing. So don't get confused. It means the same thing. So this is a quadratic as well. So I'm going to give you all some questions to do by yourself. Identify if it's a quadratic or not. Okay. So I need a volunteer. Question 4. What do you think that is?
Not a quadratic.
What about the rest of you all?
Not a quadratic.
Yeah, that's not quadratic, right? Because okay, that is definitely not a quadratic. Definitely. I don't know what you'd call that. You would have okay, let me not confuse all but if any of you guys are going to do pure maths, you're going to see expressions like this that are not in the explicit form. You'd call these implicit equations because y is not the subject of the formula. You'd have to make y the subject of the formula before you do anything. Yeah. So like I have a question, right?
Wait,
Serena,
what?
Jelani.
Wait,
You,
I'm confused. No, you're scared, man.
okay, sorry. I just given all this some insight into pure
Hey,
maths.
you're trying to make y the subject of the formula.
Yeah, so Jelani, for a function, isn't y the subject
Right.
of the formula? Isn't y the subject?
Yeah, but it's in the
Yeah.
form f of x.
Y and f of x mean the same thing. But if you
Yeah.
look at this, y is not the subject of the formula, right? It isn't. So if y is the subject of the formula, you say that it's in an explicit form now. It's right there. But if y is not the subject of the formula, you say it's in the implicit form. It's not obvious.
So it's the y before the equation is not the same thing as inside the equation.
They are the same y term.
Oh,
So if you wanted to make this the subject of the formula y, this is what you ought to do. You see that xy on the right-hand side?
yeah.
Doesn't that have y in it?
Yes.
So I need to move it across. So that'll become y minus xy, and that'll be equal to,
3.
right? We are trying to make y the subject of the formula to see what the function actually is. So I will then pull out y, because you see now y there and y there, and you see now y in two places.
Yeah.
Yeah, so I'd have 1 here, and I'd have minus x here, and that would be equal to 3. And then to
Oh,
and then to find for
okay.
y, you'd have to divide both sides by what?
1 minus x.
So you'd see that this function is actually 3 over 1 minus x. Does
Oh,
that look anything like a quadratic? Remotely like a quadratic?
no.
No. Guys, that look like a
Yeah,
quadratic?
I understand now.
So anytime you have an expression with multiple y's, my advice is you should probably make y the subject of the formula. Because unless it's in the explicit form, it can't make too much assumptions. But this is not a quadratic. I feel like I confuse real people with that. So I'm going to just backtrack a bit and explain it again. So, Christian, if you just by looking at this, does that look like a quadratic? Yes or no?
No, sir.
No, that'll look like a quadratic. Now,
Yeah.
Vanessa, does this look like a typical function?
No.
No, Vanessa, for a typical function, what is the subject of the formula?
Why?
Why? Why is the subject? Is y the subject of the formula here?
No.
No. So if you really wanted to see what that expression, what that function is, you need to make y the subject of the formula. All right? So you see how we have xy over here on your right-hand side? Yeah, Vanessa? You see that?
Yeah.
If we wanted to make y the subject of the formula, wouldn't all the y terms need to be on one side alone?
Mm-hmm.
Right. So you see this xy over here, does it belong here?
No.
Nah, so I could take it and I could move it across. And if you move something across the equal sign, what happens?
It turns negative.
Yeah, it turns negative. So that's going to become y minus xy is equal to.
3.
All right. Now, Nia, you there?
Yes, sir.
Nia, do you understand that this y is not the subject of the formula there? Can you see that y is not the subject of the formula?
Yes, sir.
I could see that too. You could see that as well. So if you really want to see what that function does, you need to make y the subject of the formula. So I said you need all the y terms to be on one side. So we took the xy and we moved this across. You're not confused, right?
No, sir.
So are you seeing y in both of these terms?
Yes, sir.
So what we could do is we could factor out the y term. So if I factor out the y term, what by y would give me back y? Tell me, what would I have to multiply y by to get back y?
1.
Right? So I could write 1 here. And if I factor out the y from minus xy, what would I write in the bracket?
Negative x.
Yeah, negative x. And that will be equal to 3. Let me know if you're okay with that.
Yes, sir.
Bet. But we're not finished yet, right? We're not finished yet. Is y the subject of the formula? Tell me, yeah. Is y the subject?
Mm.
So if y is the subject, that means y is the only thing there. If you look at the left-hand
Yeah.
side, is y the only thing over there?
No.
Nah. Right now, y is being multiplied by what?
I want a negative x.
Uh-huh. So if I want to make y the subject, I need to do the opposite so it will cancel off, right? So I would divide both sides by 1 minus x. And when I do that, and you can see for yourself, these two things cancel off.
Yes.
So my function is actually y is equal to 3 all over 1 minus x. Is y the subject of the formula? No.
Yes.
Yes. So guys, everybody, could we see that y is the subject of the formula here? Meaning that all the y terms on one side and you just have y is equal to something. Christian, some of you seeing that?
Yes, sir. So, yes, sir. But, sir, can you explain it again, sir? Because I got lost at the second part.
Okay, not a problem. But before I do that, Akira, I see you join class. I wonder if you understand.
Yes, sir.
Okay. Akira, when you look at this, is this any typical form of a function?
No.
Nah, because in a function, what is be the subject of the formula?
F of x.
Which is y.
Y, yeah.
But y is not the subject here, right? Is it?
No, sir.
Nah. So if you really want to see what type of function it is, you should make y the subject. Okay. So, Christian, happy that you tell me you get confused. That's good. The honesty is good. So, Christian, in functions, y should be the subject of the formula. Do you know what that means? Tell me if you know what that means.
Yes, sir. I know what I mean, sir.
All right, but I'm still gonna explain it here just for safekeeping. If y is the subject of the formula, then all the y terms will be on the left-hand side, and only y will be on the left-hand side. But Christian, when you look at this, we have a y term here, and look at the other side from what you have on the other side.
XY plus 3.
Are you seeing any other y terms there?
Yes, sir.
Ah, but if y is the subject of the formula, then all the y terms supposed to be on one side. Do we
Yes,
have
sir.
all the y terms on one side, or like one of them on the left hand and one of them on the right hand side?
One of them on the left hand and one of them on the right hand.
Yeah, it can't have that happening. So what we're gonna do is we're gonna take this xy and we're gonna move it over. Now, that is equivalent to taking away xy on both sides. Think about it, Christian. If you want to take this and move it across, so tell me, what would I have to do to cancel xy? Like, what would I do to get rid of xy? You see if you can figure it out. Okay, I can give you an example. Imagine you had the number 5. What would you have to do with the number 5 to get rid of it?
-5 from it.
Yeah, minus 5. So if I want to get rid of xy over here, what do you think I would have to do?
Minus the y by y.
Now minus xy. Check it out again for yourself, right? If you want to get rid of 5, wouldn't you say 5 minus 5?
Yes, sir.
Yeah, if you want to get rid of this entire thing, that entire thing come like 5, you know. I would just minus xy. Make sense?
Oh, yeah. Understand.
Because that come like, okay, look at a simple example, right? What's 2 by 7?
2 by 7 is 14.
Right? If you wanted to get rid of 14, wait a minus.
Minus the minus 14.
Yeah, minus 14. You'd see minus 14, right? And another thing you could do. And you could say 2 by 7 minus 2 by 7.
Yeah, you could say that too.
So, like, how is that any different from this? It's the same thing, you know. The x could be 2 and the y could be 7. And it's just minusing the exact same thing from itself. So,
Oh,
it's just canceling off now. Xy minus xy. And whatever you do on one side, well, you had to do it on the other side, right? So, the common trick for this and how people just memorize it, anytime you take something and they move it across, the sign changes. So you see how we have positive xy here?
yes, sir. Yes, sir. I know this. It has changed. If you have positive, it'll change to negative.
But now you know why, right? Because you want to get rid of it over here. So you'd have to take it away. And when you take it away
Yeah.
on that side, you take it away on this side. So that is really why how it does work now. So we move across the xy, and now we have y minus xy is equal to 3. Seeing that, right?
Yes, sir.
Are you seeing that? Now, y is still not the subject of the formula. Matter of fact, only y should be on the left-hand side. But I seen y over here, and I seen a x by the y. We can't have that. So what we need to do now is pull out the y from both of them. And that's what we need to do. So I'm going to pull out the y. So tell me, Christian, what would I need to multiply by y to get back y?
1.
1. So y by 1, okay. And we have minus xy over here. If you pull out the y from that, what would you write?
Negative x.
Right. And that'll be equal to the 3, right? Now hear this. We want to find for y. We want to find for y. Right now, y is being multiplied by this big bracket over there. So to find for y, you would need to cancel this off. So what's the opposite of multiplying?
Divide.
So you could divide by 1 minus x on both sides. And that is how you make y the subject of the formula. And this is now the complete function. Because for a function, y is the subject of the formula. And so when you look at this, it can make a 100% correct statement, and you could say, well, nah, this don't look anything like a quadratic. Yeah. This look like a quadratic to you?
Nah, sir.
Nah. So the whole point of doing that was just to make it in a function form now, so we could see exactly what it was. Over here, it's not exactly the form of a function. But when you write it like this, you could clearly see what it is. Somebody pick up.
Okay.
Oh, yeah.
Yes, sir. I understand. So I understand.
All right, bet. Okay. Kaylee, number 5. What do you think number 5 is?
So I think number 5 is a quadratic.
And what if I told you it was not a quadratic? What would you tell me?
I will hold my head, sir.
Let me show you something, right? Let me look at something. All these graphs you could actually plot it. You could actually plot all of these graphs. So let me show you something. And they're gonna be like, what? From the starter class, and that's a quadratic could either look like this or it could look like this. That's what we discover, right? Yeah?
Yes, sir.
Okay. What is right? Y is equal to 7 divided by x. Plus 3x squared. That graph looking kind of weird, eh? You seen that?
Yes, sir.
Yeah, that graph looking like that don't look like a quadratic. Or you find that looking like a quadratic?
No, I take back what I say.
We had to understand why is not quadratic, right? But everybody in class, can we see that that is not quadratic? Like if we graph it out, does that look like a quadratic? Tell me, guys, does that look like a quadratic?
Yes, sir.
No,
Yes,
sir.
sir.
No. Christian, does that look like a quadratic?
No, sir.
Nah, Christian, I tell you, a quadratic is either a smiley face or a frown. This don't look like either one. It look like a mixture of both. That's
Yeah.
actually that's actually a cubic function to the power 3. Um, let me just briefly explain why. Jelani, do you know why this is not quadratic? Tell me, Jelani.
Yeah.
You're doing odd maths, right? So if you wanted to find the roots for this thing, you'd put the y value equal to 0 because the roots would occur when the y value is 0 because of the x-intercepts. So you would say 0 is equal to 7 over x plus 3x squared. Now, to get rid of the fraction, you'd multiply by x on both sides. Why? Well, right now you have 7 divided by x. You don't want to work with fractions, so you'd multiply both sides by x. So it'd cancel off now. When you do that, Jelani, n0 by x is 0, 7 over x by x is 7, and what is 3x squared by x? Tell me, Jelani, what is 3x squared by x? Anybody know what is x squared by x? Does anybody know how the rules for indices work?
Um. So repeat after me, my bad.
3x squared by x.
3x squared by x. That's I remember. That's like an indice, like 3x squared over x, right?
Nah,
And your
that'll be
minus.
nah, that'll be 3x cubed. Why? X squared.
Oh,
X squared means x by x, and you're multiplying another x. So it comes
yeah.
like you're multiplying x by itself 3 times. So that's x equal to 3.
Oh, okay, okay.
Long story short, does this look like a quadratic? If the highest power for
No.
x is 3. No, no, no. For the others in class, I don't want to sound like a rabbit hole, but this is clearly not a quadratic. And the reason I know that is because I have 7 over x. Yeah, you're seeing the x squared, but you have 7 over x. This is not a quadratic. Right? That's not a quadratic. That could never be a quadratic, so no. Right? Um, guys, are you understand why this is not quadratic? Because you have 7 over x. I'm wondering if you're seeing that. You have 7 over
So
x.
is it? So is it like something to do with law indices?
Yeah,
Why is it not a quadratic?
okay. It's not quadratic. Okay, if it's a quadratic, it's going to cut the x-axis 2 times. That's one of the key definitions of a quadratic. It's going to cut the x-axis 2 times. If it has real solutions, it'll cut the x-axis 2 times. But like I just showed you, if you put this equal to 0 and you attempt to find the roots, you are going to get something to the power 3, which means you're going to cut the x-axis 3 times. And when I actually did the graph, it didn't cut the graph 3 times, but you see like it dip. Watch, like you see what I mean now? Like 1, 2, 3.
Yeah. Because I was thinking about it. So like if I just simplify it, I'll just have 3x squared over x and just you finally
You,
you get the highest power of one.
you
The
wouldn't get
x.
3. You wouldn't get 3x squared over x.
Oh, okay.
Wait, you thinking to find the LCM?
Yeah.
Okay, if you find the LCM for that, it wouldn't be 7 of no. If you find the LCM for this, it would be because 1 could go into x times, and 3x squared by x is 3x cubed. It would really be
Right.
7 plus 3x cubed over x.
Okay.
And again, that is not to the power 2, so that could never be a quadratic.
Okay.
Long
I
story short, if all you see x is a fraction, no, that could never be a quadratic. Never, never. All right. Let me ask Sienna this one. Sienna, what do you think about question 6? You think that's a quadratic?
Yes, sir.
Yeah, that is a quadratic. Does everybody agree that that is a quadratic?
Yes,
Mm.
sir.
Guys, if all are confused, let me know, right? I just try to show this, expose you guys to like some higher level maths, but I know what sometimes it's be confusing. But let me know if all understand why 6 is a quadratic. Let me know. Christian, you
So,
confused by now? You confused
so
by now?
because the power is 2, sir?
Yeah, it's just to the power 2. Yeah. Right? Christian, what about 7? Let me see if you can figure this out. And Keely, you'll tell him if he's correct, right? Keely, you'll tell him. 7. What do you think 7 is? So check out the form of a quadratic, right? The highest power of x is 2. Highest power of x is 2, without any fractions or anything. So check this out and tell me if that looks like a quadratic. Christian?
Yes, sir.
Yeah. What do you think 7 is? Quadratic or not quadratic?
Quadratic because the x is to the power 2, sir?
Yeah, yeah. And if you compare this to this, it's looking kind of similar, right? I mean, you have the
Yes,
x
sir.
squared, you have the x, and you have the number c. Kelly, let me know if you see that, Kelly. Kelly, talk to me. Seeing that?
Yes, sir. Yes, yes, yes.
Yeah, sure?
Yes, that's sure. It's just the one with the fraction that I'm confused. But I understand now because when it have a fraction, then it's not quadratic. Well,
Exactly.
x is the fraction, yeah.
Exactly. Because, Kelly, if you go to get rid of that fraction, right? If you go to get rid of this fraction, what would you have to multiply by to cancel off with the x here? Tell me. Tell me,
You have to
Kelly.
multiply by the 3x squared.
Nah, nah. If you had 1 over 5, what would I need to multiply 1 over 5 by to cancel off with this 5?
1.
No, 5.
Wait, no, 5, sorry.
5. Okay, let me make sure you understand it. What would I need to multiply by here to get rid of the fraction?
You need to multiply by 3?
Yeah, because I am dividing by.
True.
So I'll multiply by.
True.
Right. Now over here, if you wanted to find the roots, now the roots is just the x-intercept, right? Guys, remind me, at the x-intercept, what do we know? Remind me, guys, at the x-intercept, what do we know? Does anybody remember?
Y is 0.
Yeah, we know that. At the x-intercept, y is 0. So if I wanted to figure that out for this function, I would say 0 is equal to 7 over x plus 3x squared. But like I just now say, Kaylee, do we like working with fractions?
No, sir.
No, so Kaylee, if you have 7 over x, right, chances are you don't want to work with a fraction. So you'd multiply by what? What would you multiply 7 over x by? So the x would cancel off.
You multiply by x
Yeah, and if you multiply by x in one place, you have to do it where?
to the other.
Everywhere, right? Everywhere. So what is 0 by x?
0.
What is 7 over x multiplied by x?
7.
What is 3x squared by x?
That would be 3. Wait, 3x squared. That would be 3x to the power of 3.
Exactly, because x squared. Wait, Christian, do you know what x squared means? Quickly, do you know what x squared means?
Sir?
Do you know what x squared means?
No, sir. I don't think so.
Okay, let me ask that question. What is 5 squared?
5 squared. Oh,
Mm-hmm.
if 5 squared is 10. No.
Nah.
25.
25. Okay, how you just don't do that? How you just don't do that?
5 by 5.
Ah, so you multiply 5 by itself how much times?
5 times.
Not quite. So the question was 5 squared, right? So I presume I just say 5 by 5. And that's what you do, 5
Yes,
by
sir.
5 is 25.
Yes, sir.
How much times did you multiply 5 by itself? Because it's 5 by 5. So
Oh,
how much
I
times?
multiply 5 by itself twice.
Exactly. So that's why we said 5 to the power 2. So is the exact same example over here, Christian, like x squared. What does that mean? That just means x by x. And Kelly, if I'm multiplying another x, altogether that's 3x's are multiplying by each other. So 3x cubed. No, guys, look at this, right? Look at this for now. For a quadratic, what is the highest power of x supposed to be at any point in time? What is the highest power of x?
2,
Yeah, but what you seeing over there?
3.
No, that can't be a quadratic for sure. No, that can't be a
So
quadratic.
I have a question.
Yeah.
The final answer will be cube roots -7/3, right? I just want to confirm because I work it out right here.
Yeah, that sounds correct.
All right.
And here what? I'm gonna show you something, right? I want you to tell me that give me an approximation for the answer. Like in the calculator, give me an approximation. What you get? Come on, Jelani. Pass. What you get for that?
Wait, let me just go back in the calculator. Um,
You're supposed to get -1.326 because that's what we effectively just found for. Supposed to get that.
I could use that.
That's if you plug it in into your calculator and work it out, that's what you just found for. We just figured out where the graph is cut in the x-axis. But long story short, because it was to the power 3, it's now quadratic. So just to wrap this up, I'm going to give you all 3 more questions that not ludicrous and not crazy. And I want you all to message me on WhatsApp or just tell me if it's a quadratic or not. Okay, so I'm giving all this some time to think on this. Right? I'm giving you all some time to think about this. Giving all this some time to think about this, right? Take some time, think about it. Think about it. I give all you 3 minutes.
So
Yeah.
what you was gonna show me on the graph? Sorry, my bad. I just wanted to see what you was talking about.
So you notice that this graph is cut in the x-axis how much times?
One time,
Right. And when it cuts the x-axis, what is the y value?
0.
Right. So that's why we put our function equal to 0. Now,
Okay.
when you look at the graph, you see that it cuts the x-axis at -1.326, which is where you're supposed to get when you find the cube root or whatever that was.
Oh, okay.
Yeah.
Alright.
Yeah, so send me a message on WhatsApp, right? Or private message me on Zoom and tell me which ones are a quadratic or not. Tell me. Serena is our boss. Is our boss. Make up yourself, Serena. You handle that very skillfully. All right, Samir, you're wrong. Number 3 is wrong. That was wrong. Yeah.
Afternoon, sir.
Good afternoon, Nikolai. Yeah, so Samir, I have a question, right? You there? Samir, let me know if you're there.
Yeah.
All right, so Samir, when you look at number 3, is this any typical form of a function where y is the subject of the formula?
Yeah.
Nah, y is not the subject of the formula in number 3. If y was the subject of the formula, then y would have been the only thing on the left-hand side. So my advice is put y, okay, make y the subject of the formula, and then make your final judgment. Kaylee, that is correct. That is correct. That is all right, Nikolai. Jelani, that's correct. That's correct. Check that chat there. See what's going on in the chats. Vanessa, you are correct. Christian, you're close. Sienna, you're correct. Nia, you're not correct. You lose 1 mark. If it was 3 marks, I lose 1 mark. All right, so I'm gonna call on some people here. Don't feel shame. All are we learning? Right? So Samir, Nia, and Christian, guys, let's look at number 3 specifically, right? I want to hear, why did you all say that this wasn't a quadratic? What was your reasoning?
Because why was it the subject for the
So
formula?
because y isn't the subject of the formula, sir.
But the question is, can you make it the subject of the formula?
Yeah.
Yeah. If you could make it the subject of the formula, and your final answer is in the form of a quadratic, then the function really is a quadratic. This here is in the implicit form. Don't get confused by that. I just saying y isn't the subject of the formula. If y is not the subject of the formula, it's in the implicit form. You can't really make any judgments. The only way you could make a judgment is when y is the subject, when it's in the explicit form. So like, Christian, Nia, Samir, Nia, why did you say it wasn't a quadratic?
The
Tell me.
same reason. And I had it as a quadratic, and then I just thought I was wrong, and then I switched it.
Yes, sir. I had other quadratic too, but then I realized the subject wasn't the y wasn't the subject of the formula, so I thought it was wrong. So I thought it wasn't.
Wait, what just? I see what you're saying now, but once you can make it the subject of the formula, it is a quadratic. Like, what if I get a question like this for CXC, right? What if I later get a question like this and they say, find the roots for this function? You might know how to do it for a quadratic, and when you see this, you might think, what is this? This is not a quadratic, and you will just lose 4 marks or 3 marks. But now all you know that's a quadratic, right? So all you're not gonna leave out any working. So let me show you something quickly. Y, and we know that's a quadratic. This look like a smiley face or a frown face, right? We know that. Okay, does that look like a quadratic, guys? Yes or no?
Yes, sir.
Yes, sir.
Yeah, it does, because it's a frown, right? Samir, and not looking like a quadratic.
Yes, sir.
Yeah. Now, I'm gonna call upon Nia. Nia, let's make y the subject of the formula here. Right, Nia?
Okay, so
So where is y right now? Where is y right now?
on the left,
Right. So we're gonna leave it on the left, and what we're gonna do?
we're gonna we'll have to move the other
Yeah, you're going in the right direction. We're gonna have to move these where?
to the right.
To the right. Okay, so y is going to be equal to what? If I move across 2x squared, what is that going to turn to?
Negative 2x squared,
Okay, what is the 3 going to turn to?
negative
Right?
3,
And what did I have on the right-hand side already?
4.
Positive 4, right?
Mm-hmm.
So y now is going to be equal to what, Christian? So Christian, do you know how to simplify and look for like terms?
No, sir.
No? Okay. So Christian, this term over here, would you say that that term is a number or like a variable?
A variable, sir.
Yeah, because I had x in it, right? And x could change, that x could vary. Okay, look at the minus 3 and the 4. Are those numbers?
Yes, sir. Those are numbers.
Those are numbers, so we could simplify. So I'm going to write back the minus 2x squared because that is the x term. Nia, if at any point you're confused, tell me. Samir, if at any point you're confused, you tell me, right? So I just write back minus 2x squared, and we could simplify this. What do you all think negative 3 plus 4 is?
1.
Yeah, negative 3 plus 4 is 1. Nia, let me know if you understand that.
Yes, sir.
Yeah? Samir, you understand that?
Yes, sir.
Okay, Samir, when you look at this, what is the highest power of x?
2.
Yeah. Are you seeing any fractional? Are you seeing any fractional? Any fractions or anything?
Nope.
No, I don't see no fractions. So like safe game. This is safe. This is a quadratic. So again, this is my advice. You don't make any inferences unless y is the subject. Okay. So guys, does everybody feel like they could tell what is a quadratic and what is not a quadratic now? Yes or no? Let me know.
Yes, sir.
Okay, Nia said yes. Akira, you feel like you could tell apart between a quadratic and what is not a quadratic? Yeah? Yeah, sure.
Yes, sir. Earlier my internet had dropped, so that's why I was logged out, but I got all these answers.
Okay, great, great. I just doing a quick roll call. By the way, Jazara, do I know you? 'Cause I seen your name here, like I don't think I've ever seen you before.
No, sir, I'm a student.
Okay, wait, let me just who's your parents?
Ryan?
Rayan? Okay, cool. I know your parents. No problem. You good? I know you joined a little late because I signed you. I forgot. Being real. But did you ever do quadratics before? Yes or no?
Yes, sir.
Yeah, okay. So I just introduced everybody to a quadratic and showed them how to differentiate between a quadratic and something that is not a quadratic. So you okay with this or no?
Yeah.
All right. Jashon, let me know what's going on. You good or not?
Yes, I do too.
All right. Serena, you okay?
Yes, sir.
All right. Vanessa, let me know what's going on.
I get sir. It's not confusing.
Okay, glad to hear that. Sienna, let me know what's going on.
Yes, sir, doing good so far.
All right. Who else to ask? Kaylee, you good?
Yes, sir, I'm wonderful.
That's extravagant news. We did anything here that was like groundbreaking so far?
No, sir.
Okay, good. So Kaylee, as discussed, there are two types of quadratics. Two types of quadratics. And the first one we're going to look at is when it has a minimum turning point. So you could tell that a quadratic has a minimum turning point. This is our minimum turning point because it goes down to the lowest point when the coefficient of x squared is less, I'm not saying it's more than 1. So let me show you what I mean by that. So quickly, Keely, do you remember the form of a quadratic? F of x is equal to what?
Why?
No. What is the form of a quadratic? It goes like ax squared plus...
Oh, ax squared plus bx plus cx.
Nah, just bx plus c.
Sorry.
Right? So it has a minimum turning point when the coefficient of x, if all you're confused about coefficient is just the number in front of the x squared. So a. You have a minimum turning point when a is more than 0, meaning that it's positive. And here's an easy way to remember this. If you are positive, are you happy or you're sad? Tell me fast. If you're happy, you're
You
positive.
happy?
You're happy, right? If you're positive, you're happy. If you're happy, you're smiling or you're frowning.
You smiling?
Right. So this is an easy way to remember it. So this is the first type, minimum turning point.
What does the plus VE mean, sir?
Oh, plus VE means positive. Think
Okay.
about it, Christian. If I say that A is a value more than 0, and if I say more than 0, eh, given any number more than 0,
67.
right? Why is it that number specifically, boy? Hey, Alia, Nicola, you hear that? Nicola, you hear what that man just now say? Okay, Nikolai, I don't know what's going on with Nikolai, but
Yes,
wow.
I
Hey, boy. All
Karin
right.
kan keyboard sa my laptop na so I can unmute just also.
The man of all numbers, the man had to say 6-7. That's what he had to say. That's what he
Yes.
had to say.
Out of all the numbers in it.
Yeah, boy. All right. So if it's a minimum turning point, then the coefficient of x squared, a is going to be more than 0. So positive values. And the way to remember this is you're happy, so you're smiling. And some
Okay.
examples would be like this. So let's just say you had a function f of x is equal to x squared plus 3x plus 2. Okay. Samir, are you able to tell me what a is from that quadratic equation there? Are you able to tell me what a is?
1 for
A is
x.
1. Yes. How much of you all are able to tell me that a is 1? If you can't tell me that, tell me no. I know we're not seeing a 1, so you might be confused, but let me hear, Nia, do you know why a is 1 over here?
Yes.
Because Nia, if I was to ask you how much x squared is seeing, how much would you tell me is seeing?
1.
Yeah, so a is 1. Christian, how much
1.
x squared is you seeing?
1.
Just 1, so a is 1. The number in front of x squared tells you the amount of x squared you have. So if you have 2x squared, that means you have 2x squared. If you don't have any number, that just means you have 1x squared. So a is 1. Right?
Yes, sir.
Kaylee, let me know if you understand that.
Yes, sir.
All right, Jazara, I know you're not seeing the 1 in front of the x squared, right? I know you're not seeing it, but tell me if you understand why it would still be 1. Jazara?
Yes, I understand.
So Jazara, how much x squared do you see in here?
1.
There's just 1. A is 1. Is there anybody in class confused by this?
Yeah.
Yeah, Nia?
So I know I don't know if this is different, but usually when you just have an X, you just assume it's 1.
Yeah,
So that is something else.
you just assume as 1, yes. If it's by itself, you assume as 1 because you just have one of it, right? If I just write x, that means I just have 1x. So you assume as 1. Okay, let's look at another function. F of x is equal to 3x squared plus 7x plus 9. Could anybody tell me what the value for a is over here? Quickly, what's the value for a?
3.
A is equal to 3. Would this have a maximum? Would this have a maximum turning point or a minimum turning point? Remind me, if A is
A
positive,
maximum.
nah, it would be a maximum. I have a question, guys. If A is positive, let me ask you a question, guys. If you are positive, are you smiling or you're frowning? If you're positive,
Smiling.
right? Sienna, you're smiling, right?
Oh, yes, sir. Yes, sir. I understand what you're wrong. Never mind.
So, Sienna, if you're smiling, are you going down to the lowest point or the highest point? Think about it.
The highest point.
Now you're going down, you're going down. You're going down until you reach the what?
The minimum.
Right. So that's why we call this the minimum turning point, because it goes down to the minimum point and then it starts rising again. You understand?
Yes, sir. I understand now.
Okay. So remind my guy, just to summarize, once the coefficient for x squared a is more than 0, we are dealing with a maximum turning point or a minimum turning point.
Minimum.
Right, we're dealing with a minimum. Jazara, let me know if you're confused by that.
That's how I understand.
You're sure? You're sure? Take any word for it, you know.
Yeah.
Okay. Let us look at the other case now, where it has a maximum turning point. Let me just label this quickly. So this is the minimum turning point I'm referring to. So we're going to move on to factorization just now. Then we have to look at the quadratic formula, then completing the square. Fun stuff, fun stuff. So we have minimum turning point over there. Let's look at maximum turning point now. Does everybody understand that the turning point is just the point at which it changes, like over here? Look, it was going down the whole time, but when I reach over here, it turned and now it's going up. So it's just the turning point. So Sienna, if I say you have a maximum turning point, it literally means that I'm going up to the highest point, and then I'm turning. You understand?
Yes, sir.
Okay. Now, I would have a maximum turning point when A is what?
Less than 0.
Right. If A is less than 0, are we dealing with a positive number or a negative number?
A negative number.
A negative number. Negative VE just means negative number. Right? And if you're negative, you're happy or you're sad?
You're sad.
Right. Right? Radhika leave you. Yeah. Then if you get a joke. You know that one Ravi B song?
Yes.
Yeah. Right. So let me give you all some examples quickly. We'll move on to some mixed examples just now. Right? So let's just say we had y is equal to negative x squared plus 3x plus 1. Quickly, guys, tell me the value for a over here. What is the value for a over here? Does anybody know the value for a over there?
-1.
So 1,
So it's just all right. Let's
a
have
negative 1.
-1. -1 is the correct thing to say in that instance. Because notice that we have 1x squared, but it's a negative sign associated with it. So it's really -1x squared. Right? Christian, I need you to tell me if you're confused by that.
Well, you can explain it again, sir?
All right, so Christian, forget about a negative sign for now, right? Forget about the negative sign for now. How much x squared is you seeing?
1.
Right, so I'm going to put on a 1. But what's the sign in front of it?
Negative. Oh.
So A is
Oh.
-1. Is negative
Yes, I
1 a
understand.
positive number or a negative number?
Negative number. So
Right.
it's a sad face.
It's a sad face, which means you're going down, you're going up to the maximum point, then you're going down. You're going up to the maximum, then you're going down. Make sense?
Yes, sir.
Great. Nia. By the way, if you have anybody in class that feeling left out, I'm sorry, yeah. Tell me. Tell me that. Just send me a message. If I'm not calling you, tell me. I don't want anybody to feel left out or something. Okay. So like, here what? I want somebody in class to give me an example of a quadratic that has a maximum turning point. Somebody give me an example now. Give me an example. Anybody in class?
-5.
-6.
Wait, I want you to tell me the full quadratic expression. The full quadratic expression that is in this form. So you can't just tell me one number. You need to tell me something in that form.
So y equals negative x squared plus 4x plus 2.
That is correct, right? That is correct. But let me just spice up things a bit. So like, what about -3x squared minus 8x plus 2? Okay. Somebody, quickly, what is A? What is A?
It is negative.
Negative 3.
Right. Everybody, we can see that the coefficient of x squared is actually -3. So once A is a negative number, think sad face. And sad face would correspond to a maximum turning point. If A is positive, think of a happy face. That would correspond to a minimum turning point. So is everybody okay with these two? The two types of a quadratic?
Yes, sir.
Yes, sir.
I need some more people to tell me. I find it real sparse. Let me know, guys. Let me know. What's going on?
Yes, sir, we
Yes.
understand. We understand.
Okay, good, good, good. So time for a quiz now. Time for a quiz. We're gonna combine everything we learned thus far. Let me how about all this. Okay, so I'm going to give you all 2 minutes, right? I think I like our challenge. So we're gonna combine everything we learned so far. So I want you all to take 2 minutes and try to identify. Okay, first thing I want you to do, put it in the proper form, right? Make y the subject. And then I want you to tell me if it's a maximum or a minimum. And I want you to justify why is a maximum or a minimum turning point. That's what I want you to do. So make y the subject of the formula. And I want you to tell me, is it a maximum turning point or a minimum turning point? And why? And why? So as soon as you get your answers, tell me. Start sending me your answers on WhatsApp, on Zoom. Send me a picture. Let me know what's happening. You know? Thirty seconds remaining. Okay, time is up. Time is up. So I didn't get any answers from anybody. So I'm a little concerned. A little concerned. Let me check the chat. Let me see what's going on in the chat. Excellent job, Vanessa. Good job, Vanessa. That's nice. Nice. Serena, excellent job. Anybody else? If you're having trouble with it, I want you to be honest with me and tell me so I can help you. So, Samir, you think you have it or you're confused?
Wait, so you're supposed to send like what we get for
Mm-hmm.
for A?
Yeah, A, B, and like for part one, part two, and part three. I needed you to tell me if it was a maximum or a minimum and why.
Okay.
Yeah. Akira, do you know? By the way, send me your answer. Akira, I feel like you finish it and you just forget to send me your answer. Kaylee, that's correct. That's correct, Kaylee. Jazara, let me know what happening. A bit tricky, a bit weird. Let me know what's going on. Can I hear Jazara? Um,
Well, I don't understand this, so I'm not gonna lie.
okay, I'm happy that you're honest with me. That's good. So, Christian, How could you tell if it's a maximum or a minimum? Tell me, Christian. How could you tell it's a maximum?
I don't know, sir. For the first one, I don't know. For the second one, it is because A is only one x squared, so it'll be A equals one.
Nah. So while I'm waiting on the answers from the others, let's check this out, right, Christian? So the form of a quadratic is ax squared plus bx plus c. So the number in front of x squared, that represents a. So if a is a positive number, that means it's a minimum turning point. So look at the first example, x squared. That means 1x squared, so a is 1. A is 1, since a is a positive number, is a minimum. You might still be a little confused. Let's look at the second example. So Christian, in this example, what is a?
A is 3, sir.
Right, because a is just simply the number, the coefficient of x squared. Now if a is 3 a positive number or a negative number?
It's a positive number, sir.
Right, so it's a minimum, right?
Yes, sir.
Okay. Now if a was a negative, what do you think that would be? Maximum or minimum?
Maximum.
Right. So you're gonna apply that same concept over here for me. Now, Christian, I know this looking a little confusing, right? I know. You're accustomed seeing y as the subject of the formula, right? You're accustomed seeing y to be the only thing on the left-hand side. That's what you're accustomed seeing. And you're accustomed seeing
Yes,
this.
sir. Yes, sir.
So if you're accustomed seeing this, then you need to make this look like this. In other words, Christian, you need to make y the subject of the formula. If you need to do that, then y has to be the only thing on this side. Y is the only thing on this side. But in this
Yes,
instance,
sir.
is y the only thing here?
No, sir.
Nah, so you have to do what with the minus 3x squared?
Take it away from the y.
I wouldn't say take it away from the y.
Wait, no. Take it away from itself, from another 3, negative 3x squared.
Okay, if you say negative 3x squared, negative 3x squared, that'll be negative 6x squared. What you really have to do is you have to add 3x squareds on both sides, because 3x squared, take away 3x squared, that would cancel off. Feel like I confused you there. Imagine you had
I understand, sir, I understand.
Imagine you had 3x squareds and you take away 3x squared. That'll leave you with 0x squareds. And you want to get rid of this, right? You don't want it to be over there. You don't want it to be over there. So you need to
Yes, sir.
add 3x squares on both sides. This 2x does not belong over here. So how would I get rid of the 2x?
No, take away 2x by 2x.
Yeah, you take away 2x, it cancel off. All right? Good. So I feel like I got the answer from most persons. So great job, guys. Jazara, I don't think I got the answer from you. Jazara, let me know if you're a bit confused as well. If you are, that's fine. That's why you're here. I don't mind going it over. Just tell me.
Yes, I was listening to what you were saying and I understand now.
But just to make sure, we can do a question together, right, Jazara? But Christian, let's look at the first one. Is y the subject of the formula here?
No, sir.
No. Could somebody in class tell me, what does it mean if y is the subject of the formula? Akira, if I say y is the subject of the formula, what does that mean? What do I mean?
Y is the well, it's only y on one side.
Exactly. Why is the only thing on one side? So Christian, tell me what shouldn't be on the left-hand side then. What shouldn't be on the left-hand side?
The 3x squared and the 2x.
Right, they shouldn't be over there. So you need to move them across to the other side. Now, when you move it across, the operation changes. So if it's like a negative, it will turn into a plus. If it's a plus, it will turn into a negative. And I showed you why. So
Yes, sir.
let's move across the minus 3x squared. If I move across minus 3x squared, what is that going to turn to?
Positive 3x squared.
Okay, well, what else do I have to move across?
the 2x squared, so it become negative 2x squared. No,
That,
no,
that,
negative 2x. Yeah, my bad.
and what was already on the right-hand side before we move across anything? What was there originally?
The 1,
Right, that which is positive or negative 1. What's that?
positive 1.
Right. Could you answer the question now? Is it a maximum or a minimum?
It's a minimum
Why? Why is that minimum?
because the 3 is not negative.
Right. So since A is more than 0, because we know it's 3, it's actually a minimum. Has a minimum turning point. Is there anybody in class confused by that and they're not saying anything? I tell you, they have nothing to be ashamed of in this class. Like, I wouldn't judge you. I'll get vexed if you don't say anything, but if you tell me something, that'll be fine. Once you're talking, I don't like silence. Vanessa, you're cool with this, right? I know you get it correct, but I'm still asking anyways.
Yeah.
All right. So, Jazara, do you understand that when I moved across the minus 3x squared, it turned to positive 3x squared? And when I move across the 2x, that turned to negative 2x?
Yes, sir.
And well, the 1 was already there, right? If the 1 was already there, we're going to do anything with that? Tell me, we're going to do anything with it if it was already there?
No.
Nah, so that remains as positive 1. So, Jazara, what is the coefficient of x squared here? Jazara, what's the coefficient of x squared? So coefficient just means number in front of x squared. What's the number in front of x squared?
3.
3. Is 3 positive or negative?
Positive.
So if it's positive, it means it's our minimum turning point. A way you could remember it, think of when it's positive. When it's positive, is we smiling or is we frowning?
Smiling.
Yeah, you had to think about that for a second. So when you're happy, you just be crying.
No.
But sometimes, when you're so happy, you just cry. Anybody is do that? I find that, I don't think that ever happened to me. Maybe once. I think my girlfriend had done like something really thoughtful for me and like a surprise, and I was moved to tears. But how much are they just cry when they're happy? Let's be real. On a regular day.
I actually do.
Why you sound like you're crying right now?
No, like, okay, I just always talk like that with friends and I'll just tell me that.
Now you actually sound like you're crying. You're watching like season 4 of Bridgerton or something.
No, I don't watch that.
You know what? That peak boy.
Oh,
I see like I would have never watched that, and I watched that with my girlfriend and like I get hooked on that. Boy, imagine a grown man sitting down with your girlfriend like drinking tea and watching that. I'm telling you. Telling you. Uh, honestly, like you never know until you watch it. It's actually a good show. But anyways, long story short, Jazara, when you're happy on a normal day, you don't cry, right? So when you're happy, you're smiling. And so this is our minimum turning point because you're going down to the smallest value, going down to the lowest point, the minimum point. So I trust I understand that, Jazara. Because when you move across everything, you notice that the number in front of x squared is 3, it's positive, so a minimum. Right. Jazara, look at number 2 now. Could you tell me, do I have anything that I would need to do, or could I just simply read off? Could I just take a simple read off for what A is? Tell me, Jazara, what do you think?
So I think you could take a read off.
I think I could do that as well, because it's already in the form, right? Ax squared plus bx plus c. So what would A be equal to in this instance?
1.
So remember, watch this, right? So if I write this in the form ax squared plus bx plus c, I want you to tell me what do you think A is? So A is just simply the number in front of x squared. What number are you seeing in front of x squared there? Be honest with me. What are you seeing in front of x squared in that equation?
So that's all. I don't know. 1.
No, look at it for yourself. I want you to read that from me. What I'm saying. Read that from me. What you saying?
ax squared plus 4x plus 2
Oh
equals.
no. Oh, I see the problem. I see the problem. My handwriting. That's 9, eh?
Yes, I was about to go say that.
Oh,
Yeah.
Didn't
Yeah.
read that.
This is 9. So just all right. You know it is not, right?
oh well, yes, it was 9.
Sorry about that.
I think
Yeah,
it was
so
that.
so A is more than 0 because A is actually what? What is A?
Minimum.
No, but what was A though? Like what was the value for A? Was
9.
it
9.
yeah, 9.
9.
So we know that A is more than 0 because it is 9. So A would have a minimum turning point as well. Great. And well, the last one. Do you all have a question, right? Just by looking at that, is it in the exact form of a quadratic? Ax squared plus bx plus c?
No,
Is it in
sir.
the no,
No, sir.
no. Jazara, could you help me just shift around some things to make it look like this form for me? Could you help me with that? Could you help me shift around some stuff? But if you're confused or if you're feeling any kind of way, just talk to me. Be honest. I'm not judging anybody here. You think you can handle the job? Just rearranging some elements here to get this? Yes or no?
So put negative 8 on the other side.
Over here?
The other way.
Well, here what? When you say other side, I'm thinking across the equal sign. I say, can't say that. Can't say. If you say across on the other side, you're talking about the left hand side or the right hand side. So I think you mean to say put the negative 8 over here. So
Yeah.
so here what just alright. You call out the final answer for me. You call out the final thing in this form for me. Call out the final thing. What should I write first?
You will do.
So tell me, Jazara. I want Jazara.
7x squared plus 2x squared
Nah, not 2x squared. That's just 2x.
minus 2x minus 8.
Great. And could you tell me what A is?
7.
Right, A is 7, so A is more than 0. So again, that's going to be a minimum turning point. Question. Could somebody tell me what B is? If I asked you what B was, do you know what B is?
B is 2, sir.
Right, somebody else. What is C? What is C? What is C? Somebody else.
-8.
Negative 8.
Negative 8.
Right, -8. Cool. So okay? So far, you should be able to tell what is a quadratic and what is not a quadratic, no matter how it's looking. So no matter how scary it's looking, you should be able to figure out if it's a quadratic or not. You should also be able to figure out if it's a maximum turning point or a minimum turning point, if the quadratic has that. Tell me, is anybody feeling lost or do you feel okay with me moving on? Tell me.
So I was away from the computer, so I didn't get the points with the maximum and minimum turning.
That's okay. We wasn't fighting for points. I just wanted students to be able to recognize, like generally speaking, if it have a maximum or minimum turning point.
Okay.
I think you're talking about minus h comma k, using completing the square to find the specific turning point.
Yeah.
Yeah. We are so far yet.
Oh, okay.
Right? Let me know. Is everybody okay to move on?
Yes.
Right? What about the rest of all you? Vanessa, Christian,
Yes, sir.
Milani, Akira,
Yes,
Slovenia,
sir.
Nikolai, Nia,
Yes, sir,
Jack.
I understand, sir.
Okay, okay.
Yes, sir.
Okay. Now we should be able to sketch a quadratic. We should be able to do that. Now, let me show you what I mean by that. Sketching a quadratic. So we know that a quadratic could either look like a smiley face or a sad face, but there's more to it. You think that was it? No, there's more to it. So I just drew a Cartesian plane over here. Oh my God, big scary term. No, Cartesian plane is just the x and y axis, right? So I had the y axis over here, and I have the x axis over here. And you would call this the Cartesian plane. So I'm going to draw a quadratic. And I want you guys to tell me, does this quadratic look like a maximum or a minimum?
Maximum.
Maximum, sir.
What it look like?
Maximum.
Right. So if we wanted to sketch this thing, well, we need to know a couple things, right? So let's see if we could figure out the things we would need to know in order to sketch this properly. First thing, we could identify that this graph has a what? It has a what? Remind me?
Maximum.
Sir.
Maximum turning point. Now, we also need to pay attention to where the graph cuts the what axis. Could anybody tell me?
The x-axis.
Yes. And you would call these the x-intercepts or the what? That's what R.
Root.
Right.
Radius.
Nah. So the x-intercept or the roots, they mean the same thing. And guys, could anybody remind me what the y value is equal to at the x-intercept? Could anybody remind me?
0.
Yeah. At the x-intercept, the y value is 0. Okay. And for you to do a proper sketch, you need to know one more thing. One more thing. So you know where it's cut in the x-axis. What else should you know? Could somebody else tell me? So like I know where it cut in the x-axis. Those are the roots. I know that I need to show the maximum turning point. What else do I need to know to sketch this thing? Anybody could give me a guess? So like I know where the x-intercept is.
Where
Wait.
got a new y-axis?
Yes. So you also need to know the y-intercept. Well, this one real easy, right? The y-intercept is just simply given by the c value. That's real easy. Just the c value. And at the y-intercept, we should also know that what? At the y-intercept, what is what? You're supposed to know.
X is 0.
0.
X is equal to 0. Cool. So whenever you need to sketch a quadratic, you need to be able to tell them, okay, this is the maximum turning point. This is the y-intercept. These are the roots. You should be able to identify those things and find those things. So the very first thing we're going to find for is the roots and the y-intercept. You need to be able to figure out those. So this is the graph for a maximum turning point. This would be the graph for a minimum turning point. Nothing gonna change really. Anybody feeling real lost? Like really, really confused? Anybody going once, going twice, going a million times? Jazara.
So I think I understand, sir, but you could like explain one more time just so I can make sure.
No problem. Give me a second, right? Let me just. Anybody here into like dark humor?
Yes, sir.
If only we had a stroke eraser in real life. The health, like the health profession would be a lot better. Like a stroke eraser. Anybody knows our stroke?
Yes, sir, yes.
Yeah.
Yeah. Unfortunately, we don't have stroke erasers in real life. Yeah. But it's a bit morbid. So it's the exact same procedure if you had a minimum turning point. So, guys, this is what I want you all to do for me. I want you guys to draw this on paper I want you to identify the x-intercepts, also called the roots. I want you to identify the y-intercept, and I want you to identify the minimum turning point and label it just like this. Do the exact same thing, but for this graph. Do that for me. So that's what you all have to do. So Christian, you'll get to see if you understand it yourself, right? So what I'm telling you all to do, I want you all, so I've drawn a curve here. I want you to label on the diagram what is the x-intercept of the roots, what is the maximum or minimum point, where is the y-intercept, so on and so forth. So take 2 minutes and do that and send me a picture of your diagrams. So let me know what's going on. All right, so Jelani, you wouldn't get full marks here. You can get full marks. All right, number one, a quadratic has two roots. So you've only labeled one point, saying that as a plural roots. So you need to label the 2 points.
Oh, okay.
Another thing,
my bad.
the minimum point is not h comma k, it's minus h comma k. It's minus h comma k.
Okay.
If you look it up on Google, you'll see the vertex form. That's what the Americans use, but the standard for CSEC is different. We learn it as minus h comma k.
Oh, okay.
So Sienna, what you have there is correct. Great. Serena? Yeah, that's correct. Right? That's correct. Samir? Excellent job. That's correct. Jazara, you know what's going on here? Talk to me. I wonder if you know what's going on.
So I don't know what's going on.
Say that again. I'm hearing you properly. All right. So let's label quickly. So Jazara, I want you to help me label something, right? So Jazara, what would I call this point over here? What would I call that?
Can I say so?
Sure.
The x-intercept
Or the?
or the root, yeah.
You wouldn't say roots, huh? Roots is plural. I said roots because it
Or
points to two roots. Because it points to now. But that would be a root. Singular. So yeah, this is a x-intercept, aka a root. Or you could call it root. All right, Jazara, redeem yourself. What would you call this? Can I hear Jazara? Okay, I see
Should be
some.
Y.
Nah. So Jazara, do we understand that this is the y-axis? Like if you look at that, that's the y-axis, right? That's the y-axis. That whole thing there is y. And what would you say that this whole
So the
thing here is?
X.
Right.
My bad.
So the graph intercepting the x-axis. So you would call this the what?
X-intercept.
Right? And your teacher will typically say root. So be familiar with both. They would say x-intercept or root. Okay. Sienna, what would I call this?
So you'd call that the y-intercept?
Cool. What would I call this?
The minimum turning point?
Excellent. So, like, Christian, I think you understand now?
Yes, sir. I understand it now.
Nice. So, if CXC asks you to sketch a quadratic, they're expecting to see all of this. So, let me move on to actually finding for one now. So to find the roots of a quadratic, you really have two routes. Number one, you could use the quadratic formula. Does anybody here remember the quadratic formula off the top of your head?
Yes, sir.
That's crazy. Thelma, that's all if it's correct.
B.
Nice, that's all wrong.
So I could say it.
Wait, I want Jelani to see if he could redeem himself.
Hold on. I have a lot of things on my head. Hold on. Okay, so X. Wait, hold on. I'll try to remember. Is it X minus B?
Nah, you're finding for
Plus
x. So you wouldn't say x minus b. X would be equal to something,
X equals to minus B plus or minus square root B
right?
square minus 2. Is it 2?
Nah,
Minus 4AC over 2A, right?
you're close, yeah, yeah. Somebody else was gonna say the answer. You wanna say it's like in one fell swoop? Who was gonna say it? Okay, I don't know who was gonna say it. Serena, I feel like you know that. Serena, you there?
Yes, sir.
Yeah, Serena, you know the quadratic formula by heart?
I think I do, yes.
I think you do as well. What is it?
Yeah, I do. X equals minus B plus or minus the square root of B squared minus 4AC all over 2A.
Yes. Vibes.
Okay.
That is it. All right. Now, for most instances, the quadratic formula is overkill. So let's learn the factorization method, and then we're going to learn the quadratic formula. Let me just write the quadratic formula here quickly. X is equal to negative b plus or minus the square root. Great. And under factorization, this is what you would do. You would write your quadratic as a product of two linear factors, put it equal to 0, and solve each factor individually. Wow, it sounds really complicated, but it's so simple, you'll see. I promise. Trust me, trust me. Okay. Now, could somebody just remind me of something? When you're finding your roots of a quadratic, what we know about the y value? If you want to find the x-intercept or the root, what is the y value? Does anybody remember?
0.
Yeah, yeah. Okay. Somebody, where's another word for the roots? What's another way I could say roots? Roots is just the what? Roots is just the what?
Intercept.
The what intercept?
Intersection.
What
The X intersection.
Right.
Oh.
Right. And at the x-intercept, what we know about y? Y is equal to what? If you're on the x-axis itself, that means you're on the x-axis. You're not moving up or down. So your y value is what? If you're not moving up or down, your y value is what?
0.
Right. And that also means that f of x is equal to what? Remember, f of x is just y, so f of x would be equal to what? F of x and y is the same thing, you know?
0.
Yeah, f of x would be equal to
0.
0. Right. So we're going to look at factorization. So on that factorization, I'm going to show you all two techniques. We're going to look at simple trinomials. Probably saying, wait, so what is that? Guys, when you hear the word try, what I mean? We think of like how much? Try. We think of
3, sir.
3, right? When you look at the form of a quadratic, ax squared plus bx plus c, how much terms you really seeing?
3 terms, sir.
Right, so this is an example of a trinomial because there's three terms. Nomial just means term. So 3 terms. So don't get confused, right? And a simple trinomial just means that the coefficient of x squared is always equal to 1. Now that is the simplest one to factorize. Then we also have the instances where a is not equal to 0. If a is not equal to 0, you look at the AC method. So let's start. Number 1, simple trinomials. I really hope I'm not confusing anybody. Look at this, guys. Look at this. If the graph cut in the x-axis, wouldn't you get an x value on the x-axis? Think about it. Let's soak in for a bit. If the graph cut in the x-axis, wouldn't it give you a specific x value? Or the loss, like all you understand what I'm saying? Like, okay, if this was 5, then at this point you would say x is what? Could somebody tell me?
5.
Yeah, x is equal to 5. So what we are trying to do is we are literally just trying to solve for x. We're just trying to see what x is. That's all. Granted that what is equal to 0. Remind me, if you're on the x-axis, what we know is equal to 0. What we know is equal to 0.
Why?
Why?
I see.
Right. Okay, so I'm gonna come up with some, right? I'm gonna just come up with some. So like, okay, I want somebody to read that for me. Read that for me. Keely, I feel like Keely should help us. Keely, read that for me.
If x, okay, fx is equal to x squared plus 5x plus 6.
Okay, before we do anything, right? I want you to tell me what's the value for a there? If you had to say what a is equal to.
A is equal to 1.
Could everybody see that a is equal to 1?
Yes, sir.
And
Yes, sir.
if a is equal to 1, then the proper name for it is a simple trinomial. Why we call it trinomial? Because I mean it's 3 terms you're seeing, right? So trinomial. Nomial just means term. Wow, what was that? Nomials are just terms, right? So if it's trinomials, it's 3 terms. Cool. And we want to find the roots. Now the first thing we're gonna write down, if we're trying to find the roots, right? What is the function gonna be equal to? At the roots, what do we know? If we're trying to find the roots, what we know the whole function gonna be equal to? Does anybody know? Does anybody?
0.
Yes, yes. I want to make sure nobody is lost, right? Remind me, guys, we are trying to figure out the x-intercept. At the x-intercept, what do we know?
Now y is 0, sir.
Yes, we know that y is 0, and y is the same thing as f of x, so f of x could be equal to 0. So if you are trying to find your roots, then this entire thing could just be written as x squared plus 5x plus 6 is equal to 0. So some of you guys would have do it in school and you would have been putting it equal to 0 your whole life and you just didn't understand why. This is why it is put equal to 0. Because you are trying to figure out for the x-intercepts, the roots. And clearly, at the x-intercepts, what's the y value? Remind me, Keely.
0.
Right, so that's why we just put the quadratic equal to 0 and then factorize and solve. So Keely, so far, do anything that's real scary?
No, not really, sir.
Okay, good. So let's learn how to factorize a quadratic. Now, what is the highest power of x over here? Somebody tell me.
2.
2. Now, if you have something and the highest power of x is 2, then what do we call that? What is the name for that?
A quadratic.
Right. If the highest power of x is 1, do you know what you'd call that? That's what L.
The lowest.
Nah, linear. Linear. So if you see x squared, that means you're dealing with a linear expression. I mean, what's it, a quadratic expression? You're really dealing with a quadratic here. And if you see x, that means you're dealing with a linear expression. Okay, if all you're confused, right? Just think back to the past sessions when we did linear programming and thing. Serena, and when we was doing linear programming, and all the equations you was dealing with, would I look like y is equal to 3x plus 2, or it'd be like 5x plus 3y is equal to 7. What was the highest power of x there, Serena?
1.
Right. So all of these are linear because the highest power of x is 1. So I just want everybody to be aware of that, right? If you see x squared, you're dealing with a quadratic. If you just see x by itself, you're dealing with a linear expression. So when I'm talking about quadratic and linear, you wouldn't be lost. All right. So to factorize this, we're going to look at the first term. I have a question. So, Kelly, what is the first term? What is the first term, Kelly?
X squared.
Right. To get x squared, what would you multiply? What by what?
X by x.
So you're going to put an x in this bracket and an x in this bracket. So, Kelly, notice that the highest power of x is 1. So what would I call these factors? Quadratic factors or linear factors?
Linear.
Linear factors. Great. The next thing I want you to do, I want you to look at the last term. What is the last term in this expression?
6.
6. Okay. So to get 6, how would I need to multiply?
You can multiply 2 by 3.
Multiply 2 by 3. Now let me ask that question. When you add 2 and 3, what do you get?
You get 5.
Ah. So look at that again, Keely. I think you realize what happened in here. I think you realize what happened.
Mm-hmm.
So look at that again. To get x squared, you say x by x. Cool. Then we looked at the last term. The last term is just 2 by 3. Now we're looking for two factors of x that when you multiply it, you'll get 6, but when you add it, you'll get the middle term. So when you multiply 2 and 3, you get 6. When you add them, what you get?
You get 5.
Right. Why do you think we didn't choose 1 and 6? 1 by 6 is 6, but
Because when you add them, you're gonna get back. Well, you're gonna get 7 when you add.
yeah, you wouldn't get the 5. Right. So long
No,
story
sir.
short, I could write this as x plus 2 by x plus 3. Yeah. Let me run through that one more time because I feel like some of you all are very confused and you're not seeing. All right. Jazara, you there?
Yes, sir.
Jazara, I want you to be 100% honest with me. Be brutally honest. You could be real honest, like in this class, you could tell me anything. You need to be real with me. You lost? You kind of confused?
No, sir, I understand.
You're sure? I find you saying that plenty. Which is a good thing if you actually understand. But if you're just saying you understand because a lot of people in the class only feeling shame, that's not a good thing. Don't feel shame on thing, eh? You sure you understand everything?
Yes, sir.
Okay. But I'm still gonna go it over just in case. So Jazara, we are trying to find the roots. Do you know what is our other name for roots? Do you know what's another name for roots?
Intercept.
X-intercepts, right? At the x-intercept, what is the f of x equal to? What is the f of x value equal to?
0.
Is equal to 0, right? So do you understand why I put the whole thing equal to 0?
Yeah.
Eh? Yeah or nah?
Yes, sir. Yeah.
Right? So I put the whole thing equal to 0 because at the x-intercept or the roots, y is equal to 0. So f of x is also equal to 0. Cool. The next thing we had to do is factorize this. So to factorize this, I'm going to open up two pair of brackets. Yeah? Two pair of brackets. Let me know if you're okay with that. So we're going to open up two pair of brackets. Jazara, if you're confused, let's go back to a really simple example. Jazara, what is x squared? What is x squared?
X multiplied by X.
Right. So x by x, right? So apply that same concept over here. You have x squared plus some other terms. So you're going to end up with two brackets. You're going to have an x in one of the brackets, and you're going to have an x in one of the other brackets. Okay, so you understand that part, right? X squared is just x by x. So I put x here, I put x over here. Yeah?
Yes, sir.
Okay, then we're going to look at the last term. The last term is 6. Could you think of two numbers that would multiply to give 6, but add to give you 5?
2 and 3.
2 and 3. Excellent. And so we put plus 2 over here and plus 3 over here. And just like that, you factorized it. Yeah. Now, let's look at the next step. So, Christian, you confused? I wonder if you're confused.
No, sir, I understand. After you explain it the second time, sir, I understand it. I
So,
understood it.
so you understand that, 6 is just 2 by 3. And well, if you add 2 and 3, you get back 5. So we put plus 2 and plus 3 over here. Yeah?
Yes, sir.
Right. You will figure this out, eh? Trust. So we are trying to figure out where the x would give us what? Where x is equal to what? So we are trying to figure out the x values that are going to give us what?
0, sir.
Yes. Now let's think to ourselves. Mark, that question, right? Anybody could answer. What is 0 by any number? What is 0 by any number in the world?
0, sir.
0.
0.
Right. So I want you to look at this bracket, right? If we could make that bracket 0, then 0 by the other bracket will automatically be equal to what?
0.
Yes. So the question is now, how could I make this bracket equal to 0? What would x have to be to make that bracket 0?
2.
Nah, 2 plus 2 is 4. So Christian, think to yourself, what is the opposite of adding 2?
Subtracting 2.
Right, so if x is minus 2, what is minus 2 plus 2?
Minus 2 plus 2 is 0.
And 0 by any... We don't care what it have in this bracket, We don't care. 0 by anything is what?
0 by anything is 0.
So did we solve the equation then?
Yes, sir.
Right. So that is why when you're solving using the factorization method, your teacher would tell you, say x plus 2 is equal to 0. But now you know why. Because if we could make this bracket 0, then we could figure out what x value would be. Because 0 by anything, it would give us 0. So you would say x plus 2 is equal to 0, and then it would move across the 2, and it would get the minus 2. Great. Now let's apply this concept over here now. What would I need to put here to make this bracket 0? Somebody tell me. What do you think? Just by looking at it.
-3.
Minus 3,
Minus
minus 3,
3.
minus 3, or plus 3.
So x is what? What value for x would make that 0?
Negative 3.
Yeah, that's the answer. And again, your teacher in school would tell you, you put x plus 3 is equal to 0, and then you would solve for x. But now you actually understand why you're doing that. Right? So you are trying to figure out what value of x will make one bracket 0. Because if I could make that one bracket 0 and anything by 0 is 0.
Yes, sir.
Yeah. So, and just like that, I was able to figure out that my roots are going to be at x is equal to negative 2 and x is equal to negative 3. Great.
So you could go through the concept again for the x plus 2, sorry.
Okay, not a problem. So, Jelani, you okay with the factorization, right?
Yeah.
All right. So, Jelani, what's 0 by anything?
0.
You understand that? Okay,
Yep.
so what we have in this bracket,
X plus 2.
right? If I could somehow make that bracket 0, and that 0 would multiply by the other bracket,
Yeah.
and what you get? Automatically, what you get?
0.
Right. So I want you to think to yourself, what would x have to be to make this bracket 0?
Negative 2.
Right, negative 2. That's the answer. X is negative 2.
And that just bring the brackets and equals to 0.
Right. Because when x is negative 2, what does it make this bracket?
0.
And 0 by anything is?
0.
Right. We don't care what you have in this bracket, 0 by anything is 0. So this is the working the teacher would show you in school. But
Yeah, that's what, yeah.
I'm showing you how it does work now. Do you now understand why
Uh-huh.
we want to figure out? Wait, do you now understand why we just put
Yeah.
that bracket equal to 0?
Yeah.
Because we're trying to figure out the value of x that when we put it in will give us
0.
right. Yeah.
All right,
Same,
answer.
not a problem. Same concept over here, We put x plus 3 equal to 0 because we are trying to figure out the value for x that is going to make this bracket what?
0.
Exactly. You see how cool maths could be?
Yes, it is.
Yeah. Yeah, boy. So like this is the general procedure. So now if I wanted, I could do a very crude sketch. That's what I could do. So guys, I'm just gonna do a random sketch, right? Obviously, I'm not going to include everything, but at least up to this point, we should know the x-intercepts and we should know the y-intercept. If you probably telling yourself, so, but you never show you the y-intercept. Well, you know what the y-intercept is. Remember, I said that the y-intercept is just a c value. And I don't want to assume that you know what the c value is, so I'll show you all regardless, but we should know it. So I want somebody to tell me, what are my x-intercepts? From what we just did, what are the x-intercepts?
What you say, sir?
I'm saying, what are the x-intercepts? What are the x-intercepts?
Negative 2 and negative 3.
Excellent. Negative 2 and negative 3. So we could say that negative 2 is over here and negative 3 is over here. Next thing, is my graph a maximum or a minimum? Look at the function we're dealing with. Is it a maximum or a minimum? Anybody in class could answer this, Look at this.
Minimum.
How about the
Minimum.
rest, how about the rest of you all?
Minimum.
Yes.
Minimum.
Could somebody tell me why is a minimum?
E is more than 0.
Because the x is more than 0, because the a is more than 0.
But wait, where's x? Where's x? Where's x?
1.
Exactly, x is 1 because it's 1x squared. Right? Great. You see, look, we learning. Nice, man. Nice. So, if I'm doing a very rough sketch, then I know my graph is a minimum now. So it will look like this. But I know that it has to cut the x-axis at these 2 points, -3 and -2. I know that. Now, guys, just by looking at this, could anybody tell me what the c value is? Could anybody do that?
6.
How about the rest of you all? Could everybody see that as well? That the c value would be 6?
Yes.
Yes, sir.
If you're confused, remember, This is a form of a quadratic. Ax squared plus bx plus c. Christian, if we compare, what do you think c is?
C is 6.
Exactly, and that tells us the y-intercept. That is telling us where my curve is going to cut my y-axis. So remember, guys, this is the y-axis and this is the x-axis. Let me just organize my graph better. Give me a second. Give me a moment. And this is just a very rough sketch here. You see that the graph is still missing some things, but it's definitely a good sketch. And sometimes this might be all CXC might be asking you to do. This might be all they're asking you to do. Label the x-intercept and the y-intercepts. So this is looking a bit wonky. I'm gonna fix that. It's looking a bit wonky. I don't like how this looking. You know what? We will work that. We'll work that. And okay, never mind that. I'm not satisfied. Maybe if I make it a bit wider. Put this in the center. Okay, cool. So could everybody see that my graph is a minimum? All you can see that or no?
Yes, sir.
Okay,
So
can see that. Where is it cut in the x-axis?
at 6.
At 6. I'm talking about the x-intercept. Where's it cut? Where's the graph cut in the x-intercept?
So it cuts in at the both roots, -3 and -2.
Right. And where is the graph cut in my y-axis? Remind me,
At
guys.
6.
At 6. So after today, you should now be able to identify what's a quadratic, what isn't a quadratic. You should be able to put something in the form of a quadratic if it doesn't look like it. You should be able to figure out what A, B, and C is. You should be able to figure out if it's a maximum or a minimum. You should be able to solve your roots for a simple trinomial and sketch it by showing the x-intercepts and the y-intercept, which is a good amount of stuff. The only thing that this diagram is missing is the minimum turning point, which we may cover next class. But does everybody understand the placements of the x-intercept and the y-intercept? Let me know.
Yes, sir.
Okay.
Yes, sir.
So here what? Copy this down or take a screenshot, and I'm going to give you all one question to do just to make sure we understand it. In the next class, we are going to learn how to factorize quadratic expressions where a is not equal to 1. We'll also look at the quadratic formula, and we will start completing the square. And one more class and, well, 2 more classes and we're done with quadratics. Yeah. Right, so Jazara, let me know what's going on. You feeling confused? Or you're okay? Okay.
What time you finishing?
Like 10.
10.
Yeah.
Any breaks in between?
Like a little break.
Oh, okay.
Feed the turtles? No.
On birthdays today, and everybody was going upstairs to eat, so
Okay.
yeah.
All right. I finished in class just now. Yeah. Yeah, guys. So Jazara, let me know if you're there.
Yes, sir.
Jazara, on a scale of 1 to 10, how confused are you?
5.
5? Okay, we need that to be lower. So I need you to tell me where you're confused.
So how you get them numbers on the graph?
Like the -2, the -3, and the 6?
Yeah. I know where I got the 6 from, but I don't know where the -3 and -2 come from.
All right, no problem. So Jazara, what would I call these 2 points? These 2 points are the what? It's cut in the what axis? These values are what the graph cuts in the y-axis. Right. Those are the x-intercepts. X-intercepts. Now, at the x-intercept, what do you know about the y value? What is the y value equal to?
0.
0. Now, y is the same thing as f of x. So, in the second line, we put the entire thing equal to 0 because, Jazara, if we're trying to figure out for the x-intercepts, at the x-intercepts, what we know again? Remind me, what we know at the x-intercept? Right there. Sorry about that. Yeah, Jazara, what do we know about the x-intercept? What is equal to 0 at the x-intercept? Remind me again. What is equal to 0 at the x-intercept?
Y.
Y. And y is the same thing as f of x. Do you understand why I put the whole thing equal to 0?
Yeah.
Because I am trying to figure out at what value of x is the y value what? I'm trying to figure out what the y value is.
Okay, I think so. I think I don't understand because they get the x, because x is equal to -2, so you put in -2, and x is equal to -3, so you put in -3.
Right. But I'm just trying to go through the concept and lead up to that now. So you understand that at the x-intercept, the y value is 0, yeah? You understand that part?
Yes, sir.
So what is happening there? So, Jazara, at these points, when x is -3, the y value is 0. When x is -2, the y value is
0.
So we are trying to figure out the x values that are going to give us a y value of what? At those x values, where's the y value? At those x values, where's the y value? We
0.
Exactly. So I'll put the whole thing equal to 0 and then I'll factorize. Why am I factorizing? Well, Jazara, we are trying to figure out at what x values is going to be equal to 0. That's what we're trying to figure out, Jazara. At what x values is going to be equal to 0. So were you okay with the factorization part?
Yes, sir.
Okay. I know it's looking a bit weird, right? But you see this? This is actually the same thing as this. I just wrote it as a multiple of linear factors. So if you were to expand this and this, you'd get back this entire thing. You're probably saying, so why you write it like this for? Well, Jazara, this is the answer to that. What is 0 by anything? Jazara, what is 0 by anything?
0.
Right. So Jazara, if we could figure out when this bracket is 0, we could figure out the value for x that's going to make the entire thing 0. Okay, that might sound confusing. So let me run it back one more time. So Jazara, if you could make this bracket 0, right? Then 0 by this other bracket would give you what?
0.
Exactly, and we are trying to figure out what the y value is.
0.
Yeah, we're trying to figure out what the y value is 0. Cool. So tell me something, Jazara. If we have x plus 2, what value of x is going to make that bracket 0? What's the opposite of plus 2?
-2.
Right. So when x is
Minus
negative 2, this whole bracket actually is going to turn to what?
0.
Right. And that 0 going to multiply by the other bracket. But we don't care about the other bracket because 0 by anything is
0.
excellent. So when x is -2, you're getting
0.
exactly. And when x is -3, you're getting what?
0.
Exactly. So you see what I just tell you? That is why I could place it over here because here again, Jazara. When x is -2, where's the y value?
0.
Exactly. So, in other words, That's where my graph is cut in the x-axis, because at the x-axis, the y value is 0. So this is -2, and this is -3, because that's where the graph is cut in the x-axis. I'm not sure if you understand that, but when you
Yes, I
factorize,
understand what you're saying.
so when you factorize and you solve it, this would tell you the x-intercepts. It would tell you where the graph is cut in the x-axis. And this would tell you where the graph is cut in the y-axis. Yeah. Okay, good. So I presume everybody
Yes, I
wants.
understand.
Nice. So I'm gonna give all you want to do quickly. So I want to just sketch this from a really, really fast. Because I had to go just now. Okay, so x squared plus 8x plus 15. So I want you to sketch the graph. And in your sketch, I want to see the roots. And I want to see the y-intercept. So your time starts now. Probably thinking 2 minutes is like a little bit of time, but if you understand the question, you should be able to do it in 2 minutes. Granted, they have a really messy diagram, but that's fine. Yo, chat. How we feeling? Nia, how we feeling?
All right. A little confident.
A little confident. Okay, we will see. We will see. All right. Kaylee, I remember like at the start, like you put like a crying emoji. How you feeling now? You feel
I feeling like
you feel
what's
like
it called? I feeling like the
it?
minimum turning point.
Okay. I see
Yeah.
it. I see it.
Yeah, yeah.
Next thing I know, you're gonna be raising up people with maths. That'll be cool. That,
Probably
that,
saying I know it's Kelly.
that worked for me, you know. Only that worked for me. I raised up my girlfriend with maths. And it was ego tea. It was ego tea. But I feel like the maths had a factor. Yeah. Gents, the goatee is work. But also maths. You can't discredit the maths. Maths is very important. All right. Okay. Serena, let me see what you have here. Great job, Serena. That's correct. That's correct. Akira, excellent job. Only getting through, man. Nice. Sienna, yep, that's correct.
So the
Roger
pictures and the graph it came out kind of weird.
That's correct. That's correct. One thing though, you had to put Okay, so wait, you see where you have x plus 3 by x plus 5? You had to put our whole thing equal to 0. Eh? You had to put our whole thing equal to 0.
All right. All right, so
Yeah, no problem. Oh, I posted a video with me eating noodles and beans and that going viral on TikTok. Like, why? Out of all things, why? Why that? Why that?
So because nobody does eat that.
But look, it lash. I ain't gonna lie. I ain't gonna cap.
I just eat that. And that's all good, sir. Trust.
It tastes good. It tastes good.
Well, I don't like red beans, so I.
Damn. I get the protein. Come on.
How could you not like red beans? Red beans is the best
I
now.
don't
Like
know.
black eyed peas is the
Nah,
best.
nah, real.
nah. Give me lentils and dal, and I'm good with that.
Dal, I don't
No,
like dal.
dal does lash though. Dal does lash. Like
Dal is the best out of all.
Oliver just like
Now,
pick up.
black eyed peas is the best.
To be fair, black eyed peas is pretty goated, but dal is up there. Like I don't know if your mother ever make a cup of dal for you and you can just drink that. Like you can literally just drink dal.
Nah, sir,
Oh,
sir, I don't like dal cause it has jeera in it, sir, and I don't like jeera.
Oh, well, you can make it without jeera.
Yeah, well, then with all jeera, it's all right, but dal not up there on my top three.
I see. Well, did you figure out the question?
Yes, sir, but I'm on my laptop, so I can't take a picture of it.
All right, well, let me correct it, right? We correct it. So, Jazara, I'm looking at you. I can't see you, but I'm looking at you, right? Yeah. So, Christian, there we go. So, if we're trying to figure out the roots, what's another name for roots?
X-intercept.
Right. And at the x-intercept, what is f of x equal to? Remind me, like, if you're on the x-axis itself, what is the y value?
0 or 15, sir.
No. Okay, 0, base 0. Let me explain why, right? If you are on the x-axis, what is the only directions you could move in? If you're on the x-axis itself, tell me, what is the only way you could move in?
Left and right, sir.
It have any up or down? If you're on the x-axis
No.
itself, no.
No,
If it
sir.
if it do have any up and down, that means the y value is 0 because the y value tells you how much to move up or down. So if you're on the x-axis itself, the y value is 0. So I'm gonna put this entire thing equal to what?
Equal to 0, sir.
Right, because I'm trying to figure out where the value for x is giving you a y value of 0. We are trying to figure out where the x is giving us 0. That's what we're trying to figure out. What's the next step?
Yes, sir. Then you break down the 15.
Wait, so we're going to open up two pair of brackets, put that equal to 0. Then we're going to break down the 15 into its factors. Right, what factors you came up with?
5 and 3.
Right, when you add 5 and 3, what you get?
8.
Right, so what you write in this bracket?
X plus 5. And then X plus 3.
Right. Mm-hmm. So then, what value for x would make this bracket 0?
-5.
Jazara, big up yourself. Big up yourself. Take a bounce for that one. Take a bounce for that one. Give me a bounce. Take a bounce. Take a bounce. Big up yourself. Big up yourself. Right? So, yeah, that's one of my answers. X is equal to -5. What's my other answer for x? Oh, they're not seeing the screen?
-2.
Yeah, -3. Bet. That's that. And this would tell you where, this would tell you the x-intercepts, right? This would tell you where the graph is cut in the x-axis. Because at the x-axis, the y value is 0. Now, I would advise you to put your full work in, right? So you'd put x plus 5 is equal to 0, and then you would move across the 5. And that's how you get the minus 5. That's the working fit. But Christian, you understand the concept?
Yes, sir.
Great. So we just figured out the what over here. What is this? What are these? What are those?
The that's where the x intersects are on the graph, sir.
Right, this is where the graph cuts on the x-axis. The x-intercept are the roots.
Yes, sir.
And where's the y-intercept?
Y intersect is 15.
Nice, nice, man. Nice, nice, nice. You're learning, you're learning. This is extravagant news. I feel like that's my saying from now on, you know. That's extravagant news. I take it from Terrence. Ever since I hear that, I stick with me. All right. So remind me, guys, what axis is this? What axis is that?
Y axis, sir.
What axis is this?
X axis.
Great. And I'm gonna put minus 3 over here, and I can put minus 5 over here. Our graph is a maximum or minimum?
It's a minimum, sir.
It's a minimum because A is what?
A is 1.
And if A is 1, that means A is more than 0.
Yes, sir.
Nice. Cool. And I would just have to label this 15. All right, so we're feeling much better with quadratics.
Sir.
Nice. I only have one person. I don't know how to feel about that. How are we with quadratics? I don't know how to feel about the silence, bro.
Good.
Well, it's sounding sad. Yeah, based on the silence. All right. So let me just give all a question for homework. I'm gonna spice things up a bit, right? Introduce some negative numbers into the picture. All right, so that's all the homework. Right, so I'll wait to sketch the graph. All right. Yes, I'll send these notes. But like collectively, how all you find today was like all you find like all you understood everything. I need some feedback.
Yes, sir. It was amazing.
Yes,
Amazing.
sir. I actually understood everything, sir. Unlike when
Okay.
I'm in school and I'm
Let's
completely
find it.
lost.
Well, happy to hear that we understanding, right? Happy to hear that we understanding. So I will see you guys in the next session. 4 and 5 people are still here just now. I might start a little bit later to give all some time to relax a bit. But yeah, later everybody. Take care. Have a good night.
Oh, yes, sir. Can you add
Bye,
me
sir.
Bye,
to the
sir.
WhatsApp group?
Bye, sir.
Bye bye. Yes. Yeah, I did see the WhatsApp group. Yeah. Right. I'll message your mom to confirm your enrollment and I'll add it to the group chat. Well,
Yes, sir.
I presume you talk to your mom and tell she that the class was okay. Whatever.
Yes, sir.
Yeah. Right. Well, I'll see you just now in the Form 5 class. Vibes.
Yes, sir.
Bet later.